As Ellen said, my name's Paul. I'm a mechanical engineer at Fast Brick Robotics. You may have heard of us, you may not have heard of us. I can tell you now that once you have heard of us, it'll probably change your life forever. So who are we? We are a robotics technology company based in Perth, Western Australia. So yes, one of the smallest cities in Australia and also the most isolated. And our focus is really outdoor automation. Our initial focus with our current project is to disrupt the construction industry, and we're doing that with digital construction products, essentially. So our first product is the Hadrian X, which is a construction robot. It's globally patented and award-winning. So the Hadrian X, it increases accuracy and efficiency, it reduces waste, it improves safety, and it is the first step in outdoor automation in the construction industry. So this is just basically we're building a bricklaying robot that does all the bricklaying for the residential construction industry. It's got its own set of challenges. This kind of outdoor automation has never been done before. The idea is relatively simple. We give the machine a CAD model of your house, and we give it a stack of bricks, and it goes and builds it. But this is not in a flat, perfectly climate-controlled workshop. And essentially what we've had to do is we've had to build a very complicated materials handling machine that is able to work in a very dynamic, a very harsh, and an ever-changing environment. So even though you see one Hadrian X robot, I and our team, we actually see a whole range of mechanical systems. From fluid power systems such as hydraulics and pneumatics, we've got pick and place robots, CNC machines, NC machines, QC and quality systems. Each of these systems is incredibly complicated, and the interaction between them is very, very difficult to manage. They've often got conflicting requirements, and so this level of complexity would have been absolutely impossible without parametric design tools and computer-aided engineering. So as you guess, we're a PTC customer, and so I just wanted to kind of give you a bit of an understanding of how we use PTC products. We've, especially in the mechanical and electrical departments, we've kept very closely to the PTC suite because we found that the ability to transfer engineering data between products has been incredibly valuable. So in the initial design stages, we use PTC's MathCAD, which is a parametric math worksheet, essentially, kind of like Maple or one of those products. This is great because it gives us parametric information, and it gets all the older engineers out of doing their calculations in Excel, where us younger engineers come along and have no idea where they got their formulas from or where their ideas have come from. So you get very basically the methodology of the calculations are very clear. So that's initial concept stage. We're using MathCAD. Once we've understood what our requirements are for the product, we go and we do all our detailed design in parametric. So that's where we spend the mechanical department spends 90% of its time. In Creo Parametric, the new PTC licensing structure, which Alan's spoken about, if you've gone to any of the PTC sessions, has given us access to advanced framework extension. This has been absolutely awesome for us. Not only has it given us really robust framework designs and really the ability to change really quickly and innovate really quickly, but it's also really helped us in our workflow. It's meant that we could the engineers can very easily create skeletons and pass the design intent onto the draftspersons and the designers. And it's meant that at every stage of the design, we've got the best person doing the job, and you don't get your engineers, sometimes as an engineer, I can get a bit focused on, what my RHS is going to look like. It doesn't matter. We let the designers do all that. As we heard in the initial customer presentation, we use ModelCheck as well. It's a fantastic tool. It's a bit difficult to customize and to get up and running for the average user, but as a company, we've got 25 plus Creo parametric users and 5 Creo schematic licenses. And as a company, it's very important to have everybody designing in the same kind of way. And so that always ensures that when a model gets checked into our PLM system, that it meets our requirements and it meets our design requirements and drawing standards and all of those kind of things. We also use Creo piping and cabling a lot. I'm kind of the hydraulics guy at Fastbrick, and so this is our hydraulic schematic or hydraulic piping assembly. And actually, there's half of it, and you can see the amount of runs. It just would have been absolutely impossible for us once we'd finished the prototype to go and try and run those lines. So piping was absolutely fantastic for working out our space claims, working out how all our components were going to fit together. And it also meant that we were able to manufacture all our hoses and all our hard pipe before at the same time as purchasing all our other parts. So there was a real concurrent engineering going on. We use model-based definition. I'll touch on that a bit in the future. Once we've got, we'll do our initial sizing and calculations in MathCAD. Once we've got a design, we verify it again in MathCAD. And then in some situations where we've got dynamic loads or difficult load cases, then we use Simulate. We also use Simulate for our, or more and more for all our dynamic kind of applications in, in the future, more and more of the robotic control kind of things. We also use the product machining suite for all our NC toolpathing and for our CNC machines when we're going into manufacturing. In the electrical design, we use Creo schematics, and at the moment we're in the process of linking the Creo schematics into the Creo parametric environment so we can develop all our harnesses in 3D. And the plan is to also do that for our hydraulics in the future. We use PTC Windchill as our PLM system, and it's used extensively across the company, and it's been absolutely fantastic. Like it was quite a long process to get it working, and it's been a big learning curve for a lot of our older designers who haven't used a PLM system like this before. But when I started at Fastbrick, it was 3 guys working on a shared drive, and you had to be so careful about how you managed your data, how you managed your saves. The model would take 45 minutes to open, and it would crash continually. And now we've gone to Windchill. We've got robust version control. We've got change management. It's fantastic as an engineer to go in and see a vendor part and be able to right-click on it and go to the documentation for that vendor part and be able to see exactly the design intent throughout the design. We also use Creo View, which is the lightweight viewer that comes with Windchill, and that's been absolutely fantastic for the guys on our shop floor. We don't actually have to give them, as an engineering department, we don't have to spell it out as much for them. We can give them the model. They've got direct access to the CAD. The procurement's got direct access to all the specifications and all those kind of things. And that's been fantastic. We don't need to do all the assembly drawings. We can give them basic understanding of how the part goes together. And if they've got specific questions, they can look at the model. If that doesn't answer it, then they can come and talk to an engineer. So a bit of a case study. Recently, we have been implementing model-based definition. I think you guys in Victoria probably don't realise how lucky you are that you've had the car industry and that a lot of your suppliers are very ready for this kind of thing. But in WA, nobody does this and nobody gets it. And so we're really trying to push this. To start with, we've just done it internally. And it's been really, really valuable. It's a single source of truth. At first, when I was doing it, I thought, oh yeah, this will be great for the NC guys. They'll be able to see all the tolerancing and the GD&T information when they're doing the tool pathing, which is fantastic. They don't have to look at any other drawings. But what we've actually found is that it's great when you're doing engineering design, when you've got to interface your part with someone else's part, all of the tolerancing information, all of the notes, it's all been brought forward in the design process. So that happens almost at the beginning. And it means that you don't have to go and look up at another drawing to see what tolerances they've set in the model. You can just see it. Also, the ability, as I said, we've stayed pretty close to the PTC suite, and that's been absolutely fantastic for our workflow and for the parametric updating of the models. It's meant that we've reduced workflow, we've reduced rework, and also going to model-based definition has meant that we're constantly reducing the overhead of drawings. When you make a change, you don't have to worry about missing a dimension on a drawing. You don't have to worry about the cost of getting someone to review it and check it release it and print it and send it to the supplier. So at Fastbrick, we've got a really diverse team. We've got engineers from the car industry in Victoria. We've got German engineers from robotics companies in Germany. We've got young engineers locally from Perth and from all around Australia. And it's been absolutely fantastic working with these guys. Like every day we get complex and novel challenges. And it's always been really cool just to see the fruit of a really good team working together to come out with a great product. So if I'm going to be here for the rest of the afternoon, if you're interested in coming and talking to me about what we do, if you're interested in coming to hear about how great it is to live in WA, how it's warm and not freezing like in Melbourne, please come and talk to me. Thanks a lot.